Hello everyone, it's January 25th. Alright, we're going to do the 26th, which is tomorrow. Alright, let's take a look. We have all elements in two binary search trees. I already did this already. This opening, because this is the second time I started streaming. The first time, my internet died after like 3 minutes. So, I've done this before in September 2020. So I was thinking the easiest way is just to grab the two sorted list and then do merge sort. And I was trying to see if it's possible to use recursion, but this recursion will be based on two trees. So I think that's probably not a good idea. Therefore, I think what I'm gonna do is just I think we probably can use I think we probably can use generator for this. So we're gonna yield, right? We're gonna yield. Okay. So we'll do this, and then yield nothing. Now that would be the first yield, right? So we return, and then here we yield. So whenever we yield, it stops. Then we're gonna check, all right? Well, how do we build if we yield? And we call these two functions, right? We call it, and we grab a value, and then we call next, right? If we yield, we just call next. Maybe yield will work. I'm not 100% sure, but yield might work. And then we can save the space. That's the whole purpose, is to save the space complexity, to make the space complexity a bit lower. All right, so anyway, we're gonna have to have DFS anyway. So I have a node, which is a tree node. It's actually optional, tree node. And then this one return, it doesn't return anything, okay? Oh, hold on, we do return something. We yield something. So let's just not do this. When the yield, all right, say if not node is return. All right, if node, and then when always DFS node.left yield node.val and DFS node.right. Is that right? Not sure. So what do we do? So DFS, DFS, DFS. I don't know, man. How do I know when to end? We'll keep calling next. And eventually DFS will end. Oh man. I don't know. While true. v1 now if I say v1 equals next dfs root 1, v2 equals next dfs root 2, so that's like the starting position. And then we say if v1 is smaller than 2 and v1 equals next dfs root 1, else rest append v2 equals next dfs root 2. When do we end? When the try? Actually, I don't know. Keep calling next. I think we'll have a iteration over, right? Next. We'll have a stop iteration. I don't know, man. Next, A. Oh. Really? A is a generator, right? So we call next A. I have stop iteration. Right, so we can say v1 stop, v2 stop, both are false. Okay, and then I'm gonna try except stop iteration, right? Then v1 stop is true. And then if v1 is smaller than v2, try it again. So v1 is going to be gigantic, right? Yeah, so let me say v1 is equal to math.inf. I can use math.inf. I can use math.inf. I don't need to use this. So while v1 is not equal to math.inf and v2 not equal to math.inf. Or one of those not math.inf. And we keep going. And the same thing, we say try, except stop iteration, v2 equals math.inf. Now when they break out, say return, res. I'm not sure. Just conjure something up. See my understanding of, I'm not sure if my understanding of generator really holds water. Let's see. Meh, I don't think so. How to use generator with Python? Generator with yield in recursion. Yield from. Because callback node. Okay, so I think it's yield from. Let's try yield from then. So instead of this is yield this, and this will should be yield from. Yield. I'm not sure. Yield from. Nah. Nah. It is incorrect. How do you yield? I seriously have no idea. Alright, let's pass it first and then we're gonna handle this yield thing. So we're gonna pass. We're gonna have to. Oh my god. Yeah, I want to pass the list, sorted list. Yeah, I don't know how to do it. Don't yield. We just say sorted list dot append. Easy peasy. Let me just do this. S1, S2, DFS root 1 S1, DFS root 2 S2, right? And then ij equals I equals j equals 0. Let's just merge sort. While I smaller than len s1 or j smaller or equal to len s2, and then by doing the s1 dot append math dot in, s2 dot append math dot in. Okay, and then we can just say while s1i is not equal to math.inf or s2i not equal to math.inf. Yeah, one of them is not even math.inf. If s1i, right, is smaller or equal to s2i, I is 2j, it's not I. Then rest append is 1i, else rest append is 2j. Okay, that's how we go. I plus equal 1, j plus equal 1. Okay, so this is this shall be right. DFS, I forgot, my bad. Sort your list, sort your list. Let's pass this first. Yeah, so let's pass this first, and then we'll handle whether there are other ways to do it. Okay, so most likely is this one. I'm going to try this one. 40 ON. Obtain the sorted list from each binary search tree. And then perform merge sort. Alright, this was my solution in the past. In order, in order. Oh, it's exactly the same. Yeah, that's the same as this time. Okay. Good point. Save a line. Wow, sorted list, it's even the same name. Yeah. Okay, so it's the same. I thought we don't have a yield-based solution. One pass traversal. Push left. Go ahead and order for 2 trees. Visit a node on the top of the stack, smallest of the 2. So I have 2 stacks. Push left. So this was visiting the leftmost. And then we push the smaller. Okay, so this is basically just saying they are traversing the tree along with getting the value, so they're not taking the value out. Okay. Yeah, this is just the traditional idea. Wait, hold on. Oh, it's the remaining. That's fine. Oh, so, huh. Yeah, that is true. It's Tim's sword. Okay, fair enough. Fair enough. Generator. Yes, this is what I want. Wait, how do you generate if node yield from yield? So it is three yields. Heap q dot merge. Huh. Interesting. Heap q dot merge. So we don't have to do this. Heap q dot merge. Merge two sorted. Hold on. Heap q merge. What do you do? Heap q dot merge. Multiple sorted inputs into a single. Wow. Wow. So, wow. Port heap q. Update use heap q dot merge to perform the merge sort. Oh, I don't even need this. We have this. Then we just need to return list heap q dot merge. This one is 2. And this likely we can do like this. Save another line. Yeah, let's try one more time. Just for fun. Wow, generator. Hmm. The overhead of a passing next cost. Here the balance down, up, chain calls out when 2019. Interesting. Interesting. Yeah, this is O(n) squared. Time complexity of yielding an item is OD, D being the depth of the nesting. So the deeper you nest, the more you have to call. Which is true, right? Because you yield from, and then yield from, yield from. So we have that many. So for every level, yeah, this is every level you have overhead, and that will be, if it's lopsided, you have n levels. So the first yield call will have to go through n levels. Second yield call have to go through n minus 1 level. So overall it's O(n) squared. Mm. Yeah, this is interesting. I don't know. I mean, I think the tail is just don't do it. Right? The tail is just don't do it. If you can help it, right? Basically, I think this is what it is. If you can help it, try not to do it that way. Generator is a different beast. Yeah, I think my thought process is like, if you can avoid it, just avoid it. All right, predict winner. You're given an integer array. Two players are playing a game with this array. Player 1 and player 2. Player 1, player 2 take turns, with player 1 starting first. Both players start the game with a score of 0, and each turn, the player takes one of the numbers from either end of the array, 0 or the end, which reduces the size by 1. The player adds the chosen number to the score. The game ends when there are no more elements in the array. Then true, player 1 can win the game. If the scores of both players are equal, then player 1 is still the winner. And should also return true. You may assume both players are playing optimally. So if player 1 take 1, player 2 can take 5, and player 1 loses. Player 1 can take 2, player 2 can take 5. Chooses 2, and player 2 can chooses 5. Chooses 5, so now we'll be left with the final score. I'll never be the winner. So, as long as there's one way to win, right? Player 1 choose 1, player 1 has to choose between 5 and 7. No matter which one you choose, player choosing this. The state. What can our state be? Number length is 20, right? Number length is 20. Can we simulate all scenarios? I guess we can simulate all the scenarios. Like I choose the first one, and then in this case, who will win? In this situation, who will win? Will the first one win or will the second one win? Right? Or if I choose this, so each will have two choices, the front or back. And once we've done that, the remaining also front and back. But how do you represent this? Bitmap, that's the first thing. And we can basically just say, if it was 0, then none of the value has been taken. Right? And then we can just say 1 means be taken. Okay, so we just given the current. Okay, so what I want to know is, given this, who will win? And then, so given a state, I'll go from the front to find the first one that's not taken on the left, the first one not taken to the right. We take it, right? So I'll take it. So basically say like in this, oh, and the score. Don't you need a score? You do need a score. First players, no, hold on. So what we're saying is the first player's score. Don't we need a second player's score as well in order to determine who's going to win? Or maybe we can do, say, the maximum score that the first player can get. And the second player's score is just the total minus this, right? So if I given a state, now I don't care about, so the remaining, the maximum score the first player can get, we can get a value. Right, we just always get the maximum score first player can get. But we don't really need a maximum score. If there is one way for the first player to win, and that's good enough. So basically the question is, can the first player win? So we pass the current score. We pass the score, the first player's score, right? First player's score. Then the question is whether the first player can win. Okay. First place. Oh, score 10 to the 7th. That is bonkers. That's actually fine. It's not bonkers. So basically just the state with the first player's score. I want to know if the first player can win. Right? So how do? We try to pick the first one, and the first player's score would be this. Right? Or pick this first player's score. And then when we pass, off. And the first player's score is actually not that. First player's score. So if we choose this, right, what's the first player's score? Like a pass to me, say the first player's score is this. What's the second player's score? It is the sum of all, right? The sum of all minus the first player's score. Sum of all minus remaining minus first player's score. That's your second player's score. We can actually write a function to get. So now that's the first player. If that one will give me a true, okay. Okay, let's try this. We do need a helper function to go through. Now I know the total, right? And I also know the first player score. So I just need the total minus the first player score minus the one that's currently still in. That will be the second player score. It's like if I take this total minus this, will be the second player score. Okay. I think it shall work. I have two states. State 1 is the first player's score. State 2 is the total. Not total, it's the sum total equals to sum nums. Right? And then what we're gonna do is def helper state into value first player P1 score, an int. It shall return Boolean value, right? First player score. Well, one would win. Well, if the first player score, so whenever we have this, we can immediately compute the second player score, right? We can compute the second player score, okay? And then I choose one and then go keep going until there's a point, right? Until there's a point where first player score plus until there's a point when everything has been taken, right? So state is int, and the length is 1 to 20, 21. So 20. Say if state is equal to 1 left shift 20 minus 1. So this, then return P1 larger equal to sum total minus P1, right? State is equal to, so this everything is being taken. Then the first player score will win. First player will win if first player is larger than second player score. Okay, that's fine. Otherwise, then we need to say P2 score, right? So we say P2 score will equal to 0, right? Then what we're going to do is find every non-taken value inside, sum them up, and then so P2 score shall be sum total minus sum something. Let's say for I in range 20, right? And then what we're gonna say is state right shift I, right? State right shift I and 1 if, right? State right shift I and 1, so this one has not been taken. Alright, so this one has not been taken. Then we say nums I. So that's the P2 score. Total score minus the remaining minus P1 score. That's the P2 score, okay? So now we have P2 score. Now I want to know if P1 can win. Then P1 can take 1. Alright, so I can take the left. And then, okay, so we say P1 take the left. So what is the left? Left equals 0, right? Then while state left shift left and 1 while not left plus equal 1, right? So we'll find the first one that has not been taken, okay? So left is the first one that's not been taken. And then same thing, right shall equal to 20, right? Right shall be 19. Okay, right shall be 19. Then we just say while not state right shift right and 1 right minus equal 1, right? So this gives us the left and the right boundary. Of course, we're just gonna move a lot, right? Move a lot, move 19 places. So 1 is not. So 0 is going to be taken. 1, that is the value, okay? So now we have left and right. So we need to say take left, okay? Take left. Then we just say if helper something actually P2 score, right? What about the state? State just take the left. Right, take the left. So it's be state or 1 left shift left. Right? 1 left shift left. So we take it and then P2 score. So if this is true, that means P2 wins. Right? So if this is true, that means P2 wins. So if this is false, right? So if not, this or not helper state right 1 left shift right P2 score. Yeah, I don't like left and right. I just go ing. I right, and then on the right become j. Okay, so So if this or this, one of them is false. Hold on, no, that's not right. To make the first wins, if this and, right? Which means no matter which one we take, P2 always lose. So if this, then we return true. Otherwise, return false. And then we just need to return helper. Well, state starting with 0, nobody's taken. P1 score starting with 0. Okay. Oh, and we now cache it. Func tools import diario cache. That shall be false. That shall be true. Arrays, nums, predict nums. Oh, that is ugly as hell. Hold up. Not 20 then. Nums.length, right? Hold on. Let's say size should be len nums. Okay, so instead of 20, that should be size. Range, size. And print binary state. Now, state, right? 0 is B. Just want to have 3. And then P1 score. What the heck? We're not printing anything? One, this is also fine. Oh, this is not fine. Oh, I see. So while I smaller than size, and while j larger equal to 0, and maximum recursion. Alright, what do we have? First of all, the state is wrong. State is wrong. I think this is wrong. I plus 1. So it has to be j minus 1. I use for I in range size. If, let's say, state left shift I and 1, Then we just break. Same thing here. J in range, size -1, -1, -1. If state, shift J, and 1, break. Oh, still maximum. But we did solve the problem. Okay. What's the next problem? I have a negative value. 8. P1 score is 0. Second one's wrong. How can it be 8? Minus nums I. For I in range size, so it's 0, right? In state, if this. And false, I read nothing, right? So P2 score initially will be P2 score initially. Nah, that's not right. Damn, we have to do P2 and P1. I have to do 2 scores. Have a P2 score. And then we say if this, we just return P1 is larger than P2. Okay. Then we don't have to do this. We get these two. Helper, P2 score, P1 score plus nums I, right? And this one will be P1 score plus nums J. And then that's going to be 0. Still, this is not right. How? 2, 4, 8. Wait, what? P1 score plus nums I. Oh, all take. Wait, hold on. If all taken, then this is all taken, right? And stay at a 1, 0, 0. Alright, we start from a 0, 0, 0. P1 score. P2 score. Can I say P2 score? Okay. And then I shall be 0. Oh, not taken. This is taken. 1 is taken. If not taken. If it's not taken, I'll break. Answer false. Ah. Return true. The question is whether the first player will win. So I'm always standing from the first player's perspective, right? So if first player that means it's true. Otherwise, I'll take the most left. I take the most right and say, okay, I'm gonna take the most left, right? And now we do this. This is the first. This is the second, right? If this is returned true, that means this one wins. I need this to return false, so this one can never win. And I also need this to return false, so this will never win. If this is false and this is false, so which means no matter which one I choose, P2 always lose, and then I return true, right? Otherwise, I need to return false. I cannot win. So what happened? What happened is 0, 0, 1. So I take 1. So this coming in. P1 is 0, P2 is 1. And then let's say, okay, I'm going to take this. Huh? Oh yeah, it's out of 5. So every round, in this round, right, so the first player wins. Which means in this case, first player lose. So I switch them around, so it's hard to analyze. First player take this, right? The second player can take 1. The first player take 5. First player win. But if second player take 5, first player take 1. 5, 3. The first player lose. It doesn't make sense, huh? It is the first player. It is the second player. If first player wins, then this one will return true. That should return false, because that means I cannot win. I don't understand. Okay, 0, 0, 0. Then let's use an even simpler case. How about 1 and 5 shall be true? First player always wins. Come on. 1 and 5, first player always wins. Okay, first man can take 5. Yeah, okay. Let's start from here. And then first player can take 1. Okay. And second player come in. And second player will take 5. Right? Why is still 3? Oh, because the second player take 5. Right? Second player take 5. And 1 will be false. Right? Which means this one will become false. Okay? And I try to run this. J. J is the same thing. Just realized J is the same thing. This one will also be false. So if both is false, which means this player cannot win, then we shall return true. Hold on. Well, it starts here if this one will win, right? So we're coming in, 0, 0 coming in, and then we say 0 will pick 1, right? They should pick 5 as well. How about the 0, 5 situation? Where's the 0, 5 situation? Yeah, if the first player pick 1, then he all lose. Start with 0, right? So I and j shall be known as j. J shall be 1. Okay, new things to print. I and j. Zero and 1. Yes. And then 1 and 1. So 0, 1. Then we do 0. Just return pick this. And second one pick this. Which give me true. Right? This one is true because if the first one picked 1 and this one picked 5, and this player wins. So it's true. One of them is true. And this one will return. Hold on. What are we looking for? What we're looking for is a scenario where one choose this. I think it is OR. Because one has two choices, right? One has two choices. Yeah, that makes more sense. One has two choices, and each choice it has to be both as failed. This I think would be right. Yep. And then now I just need to cache this thing. And everything will appear only once. Okay. I mean, I can actually put this one up, but it's fine. Okay, run this. Wrong answer. Ooh, a single one. A single one. Interesting. A single value shall return true. Huh. A single value. Size is 1. If state equal 1, left shift 1 is 1, 0. That's 2. Minus 1 is 1. If state equal 1. If state is not equal 1 because state comes as 0. And for I in size 1, so I equals 0. State break. So I and j is representing the same one, same thing. And then helper. So come in here. So 1 left shift 0. That's just 1. State is 1. So this larger equal to is true. Hold on, which means I pick this. I pick this and go to the next, right? Go to the next. Someone like I pick something, then go to the next. Oh. And they're equal. Basically, I say I pick something, then we go to the next level, and then our score is equal. How should we handle this? Because equal can go both ways. You don't know which one is which. It could be like I pick, like if it's even numbers, right? I pick one, you pick one, I pick one, and then you pick one, and eventually the last one pick. Kind of, it depends, right? Because the first pick, the second person pick. So when this happens, depends on if we have even number or odd number. If it's even number, then this round, this is the first one. Yeah, I just think about like I can pick one and you pick one and I pick another one. And when I pick another one, it's equal to, and I say, okay, it's when the first person wins. But if I say the first person wins and I go back there, yeah, equal is a little bit tricky. And I cannot say smaller equal to, right? And that would be like this person wins. So one pick, like I pick a value, right? And then the next round, P2 is the first person, right? P2 is the first person, and then we say if P2 wins, then P2 only wins if it's larger than, right? If it's equal, if P2 pick something that's equal, then still P1 wins. P2 just cannot, I cannot claim a win. But if it's my turn, lordy. So I do think it's so if it's even, right? P1 first pick, then P2, then P1 and P2, right? So this is actually P2, right? So when you decide, P2 shall lose. So it depends, right? It depends. So if sum total, right? If it's even, odd number, then this is actual P1, right? This is the actual P1. And we shall say P1, pick a value, right? Of the pick value, we go to the second round. The second round is P2. And then in this case, it's P2 looking at it. And we need P2 to lose in this case, right? So if sum, yes, if sum is odd number, P1 is the last one who pick, and then we go to the final one, it's P2. And then we decide whether P2 can win or not. So this is P2 can only win if this, right? Now if it's even number, then the next one is P1, which means else Nope. Oh, sum total. It's not sum total. It's size. Okay. Try again. Yep. We pass. Now this is just how do I explain? Right? So recursion with memoization. A very important trick is at the end. Whether there are even or odd number of items to pick. If there are even number of items, then the last recursion happens when P1 score is indeed corresponds, right? Indeed corresponds to a indeed corresponds to the first player. Thus, the winning condition is P1 score larger equal to P2 score. If there are odd number of items, then the last recursion happens, right? Last recursion happens with P2 score, with P1 score corresponding with corresponding to the second player. Thus, the winning condition must exclude the equal sign. Oh, 2 to the end. We run a 193, 23% rank. All right, I'm gonna check the solution now. Recursion. I guess this is counting all possibilities. O(n) squared. How's yours? Well, I'll have lots of state, and this doesn't really can handle state. 2 pointers. Alright, I'm gonna read these more carefully, so I'll just end it right here. I'll see you guys tomorrow. Adios.